S. Chan presents Educational Video Lectures as per the new UGC curriculum. Difficult concepts made easy. Study anywhere, anytime.
In this part of the video, we will be learning about determinants of matrices and certain applications which are connected with matrices.
If you want to study this topic in detail, refer to these books from S. Chan Publishing and Vikas Publishing House. Link is provided in the description box.
Welcome to S. Chand Academy, and I am Anmol Bhatia. The course that we are covering is Business Mathematics, and the topic that we are covering is determinants of matrices. And here, firstly, we will be understanding that what is a determinant and why is it required. So determinant is basically a real number that is connected with the square matrix only. Let's say we have a case of 2 by 2 matrix, and in that particular case we have a matrix which is having an element A, B, C and D, and we want to find out the determinant of the matrix. Determinant, as I have told you, is a real number, and that real number is required. So how do we calculate it, or what is the procedure for finding out that determinant? So what do we have? We need to multiply these two elements together. So D multiplied by A, and that is termed as a down product. And we use a negative sign and we go with the multiplication of these two numbers. That is called as the up product. So A into D is AD and C into B is BC. So we use a minus sign here. So the procedure is down product minus up product. So down product is the product of these two numbers, and up product is the product of these two other elements. So the procedure I have told you, and let's have a look at an example in which I need to find out the determinant of a particular matrix. So I have a matrix which is 1, 2, 3 and 4, and we need to find out the determinant of that particular matrix. So for that situation, I have told you that we need to go with down product and then the up product with the minus. So 4 into 1 is 4 minus 3 into 2 is the up product. So 4 minus 6, it is minus 2. Minus 2 is the real number, it's the magnitude of that matrix, which is termed as determinant. Then we have a procedure to find out the minors and cofactors of the particular matrix. So we have to find out, sometimes maybe in the question it is required to find out the minor of a particular matrix and cofactor of the particular matrix. Let's say if the question says that we want to find out M13, which is minor associated with the 1, 3 part. So for this, what we need to do, 1, 3 indicates that we have to remove the first row and the third column. And the remaining elements that we have, we need to calculate the determinant of that remaining element. So to find out the determinant of the remaining element, I have told you that we need to go with the down product and then the up product. So 2 into 2 is 4 minus 1 into 0 is 0. That means we will get this value as 4. So minor, which is associated with the 1, 3 element, that is 4. And similarly, if we want to find out the cofactor of this 1, 3, so cofactor of 1, 3 is the same, which is the minor, but it has a negative or a positive sign associated. So what is that negative or a positive sign? Minus 1 raised to the power the sum of these two elements. So sum of 3 and 1, which is 4. So minus 1 raised to the power 4 is positive 1. That means the cofactor is numerically equal to the minor. That means cofactor and minor in this particular situation are equal. So this is the case in which we want to find out the minors and cofactors that might be applicable in finding out the adjoint of the matrix or the inverse of the matrix. So for the minor, I have told you that we need to remove the first row and the third column, and to find out the determinant here, and for the cofactor positive sign is coming. Why there is positive sign? Because we have to use minus 1 raised to the power 3 plus 1, which is 4 in this particular situation. So we got 4 here, positive 4. Then a 3 by 3 matrix is there, and we need to find out the determinant of a 3 by 3 matrix. So for this we have a specific procedure, and just look at that specific procedure. For finding out the inverse, we have to use plus, minus and plus parts here. So plus multiplied by this minus 1, that means we have minus 1, then I use a bracket. Then minus 0 is here, so we'll use minus 0, then I'll use a bracket again. Then we'll have plus 4, we'll write plus 4, then again a bracket. So for minus 1, what we need to do, we need to remove the first row and the first column. And the first row and the first column is removed, then you are left with certain elements. So those elements are a 2 by 2 matrix, and find out the determinant of the value of that particular matrix. So the down product, which is minus 2, then minus 1 into 0 is minus 0. So this is as far as the first row and the first column is concerned. So for minus 0, what we need to do, we need to remove the first row and the second column. For what? For the minus 0 situation. So herein you will get 3, 0 and 1, 1. So for this you will multiply these two numbers, 1 into 3, it is 3, minus 1 into 0, it is 0. Then for the third part, you have to remove the first row and the third column. So first row and the third column needs to be removed, and you will get the elements and go with the down product subtracted by the up product. So minus 3 minus of minus 2, which is plus 2. That indicates that you will get minus 2 minus 0, that means you will get a value of minus 2 here. You will get a number which is minus 2. Then you will have this 3 minus 0 multiplied by 0, which is 0, and minus 3 plus 2 will be having a number which is minus 1. So ultimately what you will get, minus into minus is plus, so you will get a number which is plus 2 plus 0 and minus of 4. So 2 minus 4, it is minus 2 value. So you will get a number which is minus 4 for a particular situation, or for a particular case in which the determinant was a square matrix of an order 3 by 3. The matrix was a square matrix of order 3 by 3, and we wishes to find out the determinant of that particular matrix. So this is the procedure that we want to follow. So I have told you that how it can be done. So you will use this minus 1, 0 and 4. So minus 1, 0 and 4, and for the first particular set you will remove the first row, first column. So you are left with this and solve the determinant. For the second, first row and the second column, you are left with this part, which is 3, 0, 1 and 1, and for the next you will get first row and the third column removed. So you will get this part, which is 3, minus 2, 1 and minus 1. On solving, you will get a value of minus 2, as we have already calculated. So we stop here for a short break. After coming back from the break, we will learn certain applications of matrices.
Now quality learning is easily available at your doorstep. S. Chand Academy brings detailed lectures based on UGC curriculum as per the New Education Policy 2020. So do not forget to subscribe to the S. Chand Academy and access the wide world of knowledge conveniently sitting within the comfort of your home. Stay connected and keep watching S. Chand Academy. Happy learning!
Welcome back to S. Chand Academy. Before going to the break, we have learned the concept of determinants, and we have seen how can we find out the determinant of a particular matrix of the order 2 by 2 or for the order 3 by 3. And we have also seen the case of cofactors and minors in the previous part of the video. Now, we will be learning about certain application portion of the matrices. Before starting this concept, or in my introductory part of this video, I have told you that we have a major problem, which is the solution, which is finding out the solution for a specific set of variables. Let's say we have a 2-variable equation or we have a 3-variable equation. So we have a set procedure to solve those equations and find out the values of the decision variables, namely x or y or whatnot. But when those variables reaches to a value, let's say 3 or let's say 4 or 5, then it becomes difficult to calculate by a general method. So we have to club all these elements together in a form of a square matrix, and then ultimately we have to follow a procedure to get the particular solution out of it. The procedure that we will be learning is to find out a solution using a rule, and that particular rule is called as a Cramer's rule. So we'll be learning the Cramer's rule in this particular video. So Cramer's rule is the rule which is used to solve the system of equations. Here, let's say we have 2 variables associated with the equation. Let's say we have an equation which is having ax1 plus bx2 plus c equals to 0. That's one equation. In the second equation, we have cx1 plus dx2, that would be equal to e. That means x1 and x2 are 2 different variables, and we need to find the solution of those x1 and x2 variables. So for that, we have to use the determinants, which are the integral part of the matrices, and find out a solution. x1 is equals to modulus of, or the determinant of, a1 over determinant of a. x2 is a determinant of a2 over determinant of a. A here basically indicates the coefficient matrix. Let's say you have 2x1 plus 3y equals to 6, and you have 4x plus 9y equals to 9. So A here indicates the coefficient matrix. Coefficient matrix means these elements. So you will write here 2, 3, 4 and 9. So this matrix is a coefficient matrix, and when you find out the determinant of that matrix, you can write it here like this. So this is common for x1 and x2, or for common for x and y. An is a general term used for a1 or a2. That indicates the coefficient matrix with the column n replaced with the constants. Constants are 6 and 9, and n indicates that particular column that we wishes to replace. So let's say if we want to write a1 from this matrix, so first column is to be replaced. That means we need to write here 6, 9 replaced by the constants 6, 9, 2 and 3. We need to write a1 here like this. And when we wishes to write a2, then in this coefficient matrix we are required to change the second column. So that would be 2, 4 and 3, 9 is to be replaced with 6, 9. And when we find out the determinant of all these matrices and divide them up, we'll get the final result. And maybe in some particular situations, when modulus or when the determinant A is coming out to be 0, then the equation may have no solution or it may have many solutions. So we have different set of cases for solving, but this would be an easy way out to find out a particular solution. So let's have a look at a particular problem for, let's say, 3 variables, and the question says that we want to apply Cramer's rule to find out the particular solution. So this is the equation that we wishes to solve for finding out the values of x, y and z. So 2x plus y plus z equals to 6, minus x plus y plus 3z equals to 1, and we have another equation which is 0x plus y minus 2z equals to minus 3. So what do we do, or what do we have here? We need to write the elements of the coefficient matrix initially. So the elements of the coefficient matrix, I can write it in the form of a matrix of order 3 by 3. So I can write here 2, 1, 1, minus 1, minus 1, 3, and 0, 1, and minus 2. This is the coefficient matrix A. And as per the Cramer's rule, I want to find out what is x, what is y, and what is z. So for x, I need to write it like this, a1 divided by a, but I want a constant. So for that, I need to use a determinant. For y, what I want a constant. That would be a2 over a, but that is there in determinant. And for z, I want determinant a3 over determinant of a. So I have told you what is a, but we wishes to write a1, a2, and a3 also. So for a1, as I have explained in the previous slide, that a1 is the replacement of the first column with these coefficients. So 6, 1, and minus 3 is to be replaced in the first column, and remaining part is same, 1, minus 1, and 1. This would be 1, 3, and minus 2. This is your A1 matrix. For A2 matrix, the second column is to be replaced and all the other elements are same. That means 2, minus 1, and 0. The second column is to be replaced by these elements, which is 6, minus 1, and 3, and 1, 3, and minus 2. This is for the second A2 part, wherein the second column is to be replaced. So for A3, we have this matrix, which is a coefficient matrix, and in that coefficient matrix, I need to replace the third column. So 2, minus 1, 0 is same, 1, minus 1, and 1 is same, and the third column is to be replaced by all these coefficients, which is 6, 1, and minus 3. Now when I find out the determinants of all these matrices, I have a particular value, and that particular value is to be substituted here in this fraction, so that x, y, and z is calculated. So ultimately, you will get these results for x, y, and z. So for x, when you solve this matrix, you will get minus 15, and this determinant is minus 5. So when you solve it, you will get a value 3. When you solve this y, you will get 5 over minus 5, which is minus 1. When you solve this z, you will get the value 5 over minus 5, which is 1. And how to solve this 3 by 3 order determinant that I have told you before going to the break. So the final set of solution is this solution, which is 3, minus 1, and 1, which was very difficult to solve by a general equation, maybe a substitution method or an elimination method. So this is a particular application of the matrices in which the major thing is to find out or solve a linear equation. There are other set of applications of matrices also, in which we want to find out an area of the triangle, and that triangle is associated with these three vertices, let's say x1, y1, x2, y2, and x3, y3 values. So what happens here, area is having this formula plus minus half, and then a determinant x1, x2, x3, y1, y2, y3, and we write here 1, 1, 1. So when we solve this determinant for a particular, from that particular method that I have already told you, we can get the value of area. So just for the sake of example, find the area of the triangle which is having these vertices. So I have told you that we have to write it in terms of this determinant, which is plus minus half times this value. So we will substitute these values, and when we solve it, we'll get this value as 22. And the next application is to find out whether these are collinear or not. So when this area of the triangle part is 0, or the determinant value is coming out to be 0, then we will say that the points are collinear. Because the area of the triangle, if the area of this triangle is 0, that means that all the points lie in the same plane. That means these points are collinear. Additionally, if we want to find out the equation of a line given with 2 points, so then also we can write it like this, that x and y are those variables in which terms we want to have an equation. Let's say we want to have an equation in terms of x, y. So for that, we will write x and y and then 1, and for the next row and the third row, we will write x1, y1 and 1, x2, y2 and 1. And when we solve it in terms of x and y, we will get a particular equation. So what we have used the same particular set. That area we have calculated for the 3 points, and the third point is this xy, and we have substituted this area as equal to 0 because it lie on the same plane, because we want to find out the equation of that particular line. Let's say for the example purpose, we have to find out an equation of the line, and that line is passing through these 2 particular points. So a line is passing through, let's say, 2 particular points, and we have to add this third point, which is xy. And if all these 3 points are lying in the same plane, then what we will do, if all these 3 points are lying in the same plane, this is the first point, this is the second point. So we'll calculate the area and put that area equals to 0. So this is the area part, which is the determinant, which is having a particular value that I have told you in the previous slide. So when you solve this determinant, you will get some equation in terms of x and y. So that particular equation is desired in the question, and that requirement is the application of matrices in that particular finding out of that particular equation. So with this, we come to the end of the video, in which we learned about the applications of matrices. Additionally, we have seen the determinant part also, and these applications include area of the triangle, collinearity, and finding out the equation of the line which is there in a particular plane. Thank you.
If you want to study this topic in detail, refer to these books from S. Chand Publishing and Vikas Publishing House. Link is provided in the description box. If you found our video interesting, please like, share and subscribe. And do not forget to press the bell icon.
All rights reserved. This video has been prepared for educational purposes only. No part of it may be reproduced or copied without the permission of the copyright holder.